Okay, so what we're doing so far is that we are finding the generic derivative, and we can see that taking these limits is kind of a lot of work. So what we're going to do is develop some rules so that we don't have to take so many limits. So we want to have some rules. First rule that we're going to look at is called the power rule. So the power rule is for something like, let's say f of x is x to the n. And we want to know, what is f prime of x? Well, by the definition, f prime of x equals the limit as h approaches 0, f of x plus h minus f of x all over h. Now what is f of x plus h? That's going to be x plus h to the n minus x to the n all over h. Now let's think about what's going to cancel here. The largest power of x in the top from this first little piece is x to the n. What else am I going to have? I'm also going to have an x to the n minus 1 times h. Then I'm going to have an x to the n minus 2 times h squared, plus a lot of other stuff. All of these other things are going to have h's in them. Then I'm subtracting off an x to the n, all divided by h. And let's see, what's the coefficient going to be here? Coefficient should be n. So I'm going to have all of these terms from the first one. Once I multiply this out, the x to the n's are going to cancel. So what am I left with? I'm left with n to the n minus 1 times h, plus a bunch of other stuff where all of these other things have at least an h squared in them, probably higher powers, all divided by h. So these h's will cancel along with everything else. So I'm going to take out an h from every term. So I get nx to the n minus 1 plus a bunch of other things that have h in them. So all of these have an h. Whenever I go to plug in h equals 0, what happens? All of these terms go to 0. So the only one I'm left with is n times x to the n minus 1. Now the process here of finding out this equation is not so much as important as the result. What we just found is that the derivative of my function was n times x to the n minus 1. Now this leads us to our first big rule, and it's called the power rule. First big rule, we'll put a star beside it. This says that the derivative with respect to x, and this is the notation that we're going to use, bring down your exponent and then subtract 1 from your exponent. So that's our first big rule. The derivative with respect to x of x to the n is nx to the n minus 1. So for example, what's the derivative of x squared? So the derivative of x squared says bring down your exponent, subtract 1. So just 2x. What's the derivative of x to the 4th? This says bring down your exponent, subtract 1, so I get 4x to the 3rd. What about the derivative of 5x? Really, we don't write it, but there's a 1 there. Sorry, not a 5x, just x. There's a 1 there. Bring down your 1, subtract 1, so I get 0. So I'm just left with 1, because anything to the 0 power is 1. What about 1 over x squared? Now this isn't x to a power, but we could write it as x to a power. This is x to the minus 2. So bring down your exponent, and then subtract 1. So try to get in the habit of writing x to a power. That'll definitely save you a little bit of time, and it'll make the power rule a lot easier. Okay, so that's the power rule. Next rule is called the sum rule. What the sum rule says is that the derivative of two functions being added together is just the derivative of the first plus the derivative of the second. So if I have different functions being added together and I'm taking the derivative, just take the derivative of each piece. Now we can't do this with multiplication or division but I can do this with adding together. So for example, what's the derivative of x to the 7th plus x to the 5th? Well, I'm just going to take the derivative of each piece. So the derivative of x to the 7th plus the derivative of x to the 5th. So this is a power, so I bring down my power, subtract 1. The next one also a power, bring down my power, subtract 1. Let's do another example of this. What about the derivative of x to the 6th plus 1 over x squared plus x? Well, I'm going to take the derivative of each piece, so it's the derivative of x to the 6th plus the derivative 1 over x squared, let's write that as x to the minus 2, and then plus the derivative of just x. So x to the 6th, bring down my power, subtract 1. X to the minus 2, bring down my power, subtract 1. And then again, we have a 1 there, we just don't write it. Bring down my power, subtract 1. So I get 6x to the 5th minus 2x to the minus 3 plus 1. So that's my sum rule, is that if I'm going to find the derivative of a sum, just find the derivative of each individual piece, and that's how you can do it. Next we have the constant multiple. So what does the constant multiple rule say? It says that if I have just a constant times a function, you can bring it out front. So we had something very similar to this when we were doing limits. Whenever we were doing limits, we could just bring out that constant. Same thing applies here. So for example, let's look at the derivative of 5x cubed. This is a constant times a function, so I'll bring out my 5. And now I have x to a power, and we know how to take the derivative of this. That's just using the power rule. So I still have my 5, so it'll be 5 times 3x squared once I subtract 1. So 15x squared. So the constant multiple just says you can bring out the constant. Let's do another example of that. How about the derivative of 2x cubed plus 3x minus 4? So the derivative of the constants, they can come out front. Also, I can split this up. So this is going to be 2 times the derivative of x cubed, once I break up the first piece, plus 3 times the derivative of x, minus 4 times the derivative of 1. So I brought out all my constants, and this is what I have. Let's look at my first piece. 2 times 3x squared. The derivative of x, we already saw that, that's just 1. Now what about the derivative of 1? Well, 1 is really 1 times x to the 0. So bring down your constant, subtract 1. So let's simplify this a little bit. 6x squared plus 3 minus 0, so I'm not even going to write it. So it's just 6x squared plus 3. Now let's look at one more. And this is an exponential. Not just any exponential, we're talking about the exponential. Go back to when we learned about exponentials, and I told you that the cool part about e, so e to the x, it goes through this point here at 1. The reason that we have this number e is because the tangent line here is 1. Tangent line has slope 1 there. Tangent line has slope 1 at x equals 0. That was how we kind of developed this e. What that means is that if f of x is e to the x, then f prime of 0 was 1. So f prime of 0 being 1 meant that when I take the derivative and plug in 0, I better get 1. This leads us to the rule about taking the derivative of e to the x. So if e to the x was not your favorite function before, now it should be, because the derivative is just itself. So the derivative of e to the x is just e to the x. So for example, what is the derivative of 5 e to the x? Well, I'm going to bring out my 5. This will be 5 times the derivative of e to the x, so 5 e to the x. Let's let f of x be 2 e to the x plus x. And let's find the tangent line at x equals 0. So remember, to find the tangent line, our answer is going to be y equals mx plus b. First thing I'm going to find is m, then I'm going to worry about b. So first let's find m. To find m, I need f prime of x. That is, let's find the derivative of 2 e to the x plus x. Now nowhere in the problem did it say I need to use the limit definition, so I'm not going to worry about the limit definition. I'm just going to use the rules that we've developed. So this says 2 times the derivative of e to the x plus the derivative of x. So I broke it up, brought out my constants. Derivative of e to the x is just 2 e to the x here. The derivative of x, remember x is x to the 1, so I just get 1 there. Now I'm looking at the tangent line at 0, so I'm going to plug in 0 here. So 2 e to the 0 plus 1. E to the 0 is 1, so I get 3. So that tells me that m is equal to 3. Next thing I need to find is b. So how do you find b? We need to use a point. I know x is 0 here. The question is, do I plug this into f prime or f? And I told you always plug it into f. So let's see, what was f of 0? F of 0 was 2 e to the 0 plus 0. So that's just 2. So far my equation was y equals 3x plus b. Plug in the point 0, 2. So 2 is 3 times 0 plus b, which means b is 2. So my equation is y equals 3x plus 2. So using these rules, we can find derivatives a lot faster than what we were doing initially.